The data lakehouse is nothing but when we say data lake is a concept of building the modern data analytical platform. Almost every one of you hear the terminology because most of you run through the ADF code. What is data lake? Data lake is nothing but you bring all of the data available to be analyzed into the data analytical platform. To design that type of the data analytical platform, we use the data lake design methodology. There is no specific rule on what data to be there and what data not to be included in data lake. If you think of a specific business, for example, if you think of the tourism business, there are tourist places data generally available in the open source, and the number of hotels in each of the attractions is available in the different, again that is available in the open source, but it's available in the different platform. For example, if you want to extract the number of hotels in the Venice, Italy, if you go to the booking.com, you will book for 1 week, you can find it out list of hotels in Venice very straight away. You can do the web scraping of the data, then you can bring it into the data lake with the help of the PYSPARK. This is where the Databricks is very, very helpful. In the ADF, we do have some limitations on like doing web scraping of the data, but Databricks don't have that limitation at all. It is unlimited functionality is available in the Databricks because it's the programming nature. It's not the coding specific nature. Anyhow, I'm little deviating it. I would like to differentiate that. I would like to say the difference between data lake and data lakehouse. Okay. You all know what is the reporting platform. Generally, reporting platform is built on the database tables. Even we build one in the data ADF course. That is called generally data warehouse. If you build the reporting platform, that project is called data warehouse. And the data lake is little different from the building the data warehouse. Data warehouse always will have predefined requirement. This is my booking data. I need to build the reporting platform on top of this booking data. I need to see which hotels are booked, which hotels are not booked, or on which price range always booking will be full or which price range booking is not full. Those type of predefined requirement. That is the nature of the data warehouse. That's how the data warehouse also designed. But the data lake do not have any specific requirement. Okay. I'm bringing my list of hotels data into my data lake, and later I can use that one to display the list of hotels in the specific destination. At the same time, if anybody want to build a hotel in the same city, he can even be able to analyze the different perspective, whether building the hotel in that city is make a profit or not. Okay. How many hotels are there, how many hotels are booked, and which month it's not booked, which month it's not booked. Those type of the requirement is little different from the reporting requirement. So the data lake can be able to support the reporting requirement as well as any unknown requirement at this point in time. In future, you can be able to support for any unknown requirement in that point in time. Okay, so the data, that's why in the data lake we are including every data all the time. That is the way the data lake is designed. Ingest first, define the output later, how we are going to use the data later. That is called data lake. So this data lakehouse is basically combining the data lake plus warehouse. So as we have seen, we can able to store the data in the files using the Databricks, and also using the tables as well inside the Databricks. So that means it is supporting data warehouse based requirement as well as data lake specific requirement. That's why the thing that we are building inside the Databricks is called data lakehouse. That is the specific terminology Databricks introduced. Okay, there is no concept called data lakehouse exist, but now they made it become the concept. It is the combination of data lake and data warehouse. Okay, I little deviated it. So the main thing I would like to show you is what all are the operations you can do on top of the data frame is available in the PYSPARK. There will be more than what I am saying it possibly existing in here, but I specifically produced data frame column filtering. I specifically created the subset of these files to show you all the possibilities available inside the the most frequently used data frame transformations. That's what I want to show to you. Working labs, data frame, basic functionality. This is the one I would like to show to you. We are little stopping on building the silver layer here. I would like to go back there, but to building the silver layer, we need to know some of the functionality of the data frame. I must say thanks for Satya because he raised the valid question on the last class. So I produced most frequently data frame transformation functions here with respect to our data so that you can able to relate it. I will quickly run through it and I will give this notebook as well as for a reference to you. So whenever you are practicing, you refer this for applying some specific functionality. Each of the functionality, for example, renaming the column or combining multiple columns together to create one single column, or you are applying the filtering on one of the specific column, the filter on numerical values and filter on the string values. And if you want to sort the data frame data, how you will do it, and sorting by descending order, how will you do that? So those type of the functionalities, I specifically bring it here. It was not in my original scope, but I thought this is needed to going forward because we have seen this one on the first week of the Databricks introduction, but I didn't give all the flavors to you. So I thought better to create this one separately. Okay, so we are going to work on the PYSPARK files existing in our data lake storage, data lake house. Okay, I'm not saying data lake storage account anymore. It's a data lake house because we are building the proper bronze and silver and the gold layer here. So the daily pricing data is existing in the PYSPARK file format. So this is a data. Okay, now we are trying to bring this data inside the PYSPARK. Okay, this is the first step we are doing it. And in this time, the data is existing inside the Azure data lake storage account. We already established the connectivity between the data lake storage account and the Databricks. So straight away, I could able to read this file and I could able to convert into the data frame. If the same file existing somewhere outside the Azure, you need to use the standard Python library. First to read that as a Python variable first. Then you need to convert that into the RDD because PYSPARK don't able to interpret the data which is outside the boundary of its known connectors. Okay, for example, ADLS we do have the direct connector in the Databricks, but for some website data we need to bring it into the PYSPARK. There is no direct connector is available inside the PYSPARK. What you need to use is that you need to use the standard Python library to read that URL data as a HTTP. That's what we have done last week as well. I quickly opened that notebook and I again also explained to you before processing silver layer. So that is the Python variable. Depending on that written data from that URL, we need to convert that into the RDD first. Then you can able to convert that into the Spark data frame. Then you can able to process using the standard PYSPARK libraries. In this case, our source data is existing in ADLS. And obviously we have connectivity between Databricks and the ADLS already established it. So the first point for bringing data into the PYSPARK library, this is where we are using the Spark. Spark is the entry point for the invoking the PYSPARK, and read is the function inside the PYSPARK to read the data from the location that you are going to provide it. And Park is the another type inside this read. Read can have read.csv, read.json. There are so many functions are available under the read. Now you are providing this path. This is the path is existing in our data lake storage account. Now this Spark, this one will return the result of this data set as a data frame. Now we are assigning that into the one of the data frame variable. Even though it's a Python variable, the data type of this one is data frame. That means it can able to hold the entire data set here. Hereafter, if you want to do any processing on this data set, you can refer this variable, and all the code we write hereafter also PYSPARK code, because this is the Spark data frame. Any code we have written it here is the PYSPARK code. We will see one by one. And I have created one small cluster as well, one node cluster. I quickly start that one to execute it and see what is happening here. And I will stop here. I will check with you. Until now, any of them you couldn't able to relate or you couldn't able to map it. All the keywords I have used so far, can you able to relate it?
Hello.
Yeah.
Amar.
Yeah, Amar.
I have a doubt. So, you are using the Spark keyboard, right? So, do you have to implement any libraries on top of this notebook?
Yeah. Okay. There are two ways to do that one. We are little going little advanced, but it should be fine. Okay, Amar. Okay, Amar. Previously we used to install called pip install to add any additional libraries on top of the existing Spark code set. Okay, but now they have given to add all of the additional libraries on top of your cluster straight away here actually. If you want to use any libraries here, so as soon, for example, I think probably we'll be doing it little later part of the course. I will be including one of the library. If you include this library here and you restart this cluster, the Spark instance itself can able to refer those additional libraries. But installing via pip also supported here. Okay, pip is only specific to this session. When you install it, that additional libraries will be available throughout this notebook. When you complete that execution, when you stop that cluster, that additional library will go away. The other possibility is here you can able to add the libraries so that whenever this cluster will be up and running, it will be available for all of the sessions.
Okay. Because I could see somewhere actually that Spark context and Spark section.
Yeah.
So some of these Spark context and Spark section was a difference, and somewhere else on see that configurations of the gen.
Okay. Yeah. Okay. If you are going to use Spark, okay, again, okay, the same difference between RDD and DataFrame, Amar, okay. If you use the Spark context, it is very lowest level of accessing the Spark cluster. There you can provide some configurations. For example, this Spark cluster need to, okay, at the moment we created, I think 13.3 Spark version. Okay, that is the version we created it for this node cluster. But for example, some of the functions in this version might be depreciated in this one. If I use the Spark session, I may not able to instruct that please support that depreciated functions as well. Okay, but if you use the Spark config SC, you can able to say that one in this specific instance, please use the depreciated functions as well. Okay, so Spark context will give more control on what libraries to be included, what libraries to be excluded, and what additional options you need to include for this Spark while running it. SC is still possible, but in the Spark session it's not possible. Whatever plainly the default configuration configured for that cluster, other than that you can't able to do anything if you are using the Spark keyword.
Okay. And one more find out.
Yeah.
That DataFrame is top of that one is the latest we are using instead of that RDD, right now.
That's right. Yeah.
Okay. That resilient it's referred that fault tolerance. So all things it will be come in a DataFrame also, right?
Because yeah, the point is, even though you declare here as a Spark data frame, okay, the Spark data frame is built as a abstract layer on top of the RDD. Okay, so when you are running the Spark data frame command, the Spark data frame itself do not have anything while executing inside the Spark cluster. The Spark data frame internally converted into the RDD. So the same features available for RDD, fault tolerance, networking, error handling, and recreating the jobs in the instant of failure, everything will look same. This is not only for data frame, this is also applicable for table as well, because the Spark is converting everything we write it into the RDD before executing into the Spark cluster.
Got it.
Good.
Thank you.
Yeah, good. Okay, so now I'm just starting the bronze layer. This is I'm just pointing to our Parquet file folder here. Nothing else I'm doing it here. I have write the code because writing it and explaining it may took some time because we need to do silver layer as well today. So I have pre-written most of the code, but I will explain to you. Mostly it's possible and I share this code with you as well. This is just pointing to my data lake storage account folder, Parquet files. I am reading it using the Spark session.read.parquet and I am giving the path. This is returning the data frame. If I want to display the contents in this data frame, we need to use the keyword called display. If you want to see what all are the columns inside your data set, then you need to use the option called print schema. This is again the PYSPARK functionality. To this, I will just run it. It will give the one is displaying the data, another one is displaying the schema name. Hopefully it's running. Yes, it's running. Okay, so this display is displaying the entire data, not entire data, couple of the records actually, and this one is displaying the how this data frame is formed, what all are the columns are there. This is just for supporting us while developing the code. Actually we use this as the functionality. Now this has got around 2 4 6 8 10 12 columns are there. Now if you want to select only some specific column from this data frame, okay, now you need to clearly see that this data frame don't change anything. Okay, this data frame will always have all of the 12 columns. If you want to select some specific column from this data frame and you want to process it, again we are using the keyword called select. Okay, and you need to refer this data frame, the data frame variable that we have assigned on top of the Spark read. So anything you need to do on top of this one, you need to refer that one. So PYSPARK has got the select function. I think all of them are functions almost. Okay, and you can specify the list of column names from your schema. This will create the new data frame. This won't alter this data frame into the new data frame. Okay, that we call it as, actually we can't able to change the, once the data frame is defined, it's a static one. If you want to change that one and you need to refer this one subsequently back, then you need to assign that into the new data frame. For your reference purpose, this is the select df. I am displaying the original df as well. The original data frame never changes as part of this select statement. Okay, it's generating the new data frame. So one of them will display all of the columns, the original one. This select one display only the state name and market name. If you see the difference between that one, you need to be aware of that one. That means just keep it in your mind. Any transformations that you are doing on your source data frame, you need to assign that into the another data frame subsequently to use it, or write that the transformed data into the somewhere in the ADLS. You can't use directly the original source data frame to write it by using selecting this column. You need to assign it back into the another data frame. Okay, that practice need to be come with you. Whenever you are transforming the data, store that into the another data frame. Okay, so the select is the one to selecting the specific columns from the source data frame, not source data frame, any data frame. Okay, you can use the select, and inside the select you can specify the multiple column names. Now the same functionality can be achieved by one of the function called call function. I will subsequently explain in the later part of the course where this is very beneficial. Okay, for example, here after selecting my column name, I want to give the different alias name for my state name, you can't able to do it inside the select. But if you are using the same functionality only, we are achieving it. But if you want to give the alias name for your source column, then you can able to do it using the additional Python function, PYSPARK function, which is existing inside the package PYSPARK is SQL.functions, and you need to import that into this one. This library is available inside the PYSPARK cluster, but it won't be available by default like the spark.read or display. You need to import that specific library into your cell, then you need to write the code on top of that one. Okay, so here what I'm going to do is that I'm going to include the row underscore ID. That is one of the column in our source. I want to change data pricing column into pricing underscore date, and another column name probably we can give alias name is, probably we can take the variety one, that is the one missing the variety underscore name. And if you give the variety underscore name, okay, now still you are using the select function. Okay, on top of the select function, previously we have selected only column names like this, we previously selected it. Okay, now you want to the previous selection just include the existing column names in the data frame. This is where it was ending in the previous select. Okay, it is displaying only 3 columns from this daily pricing. Now one column I am selecting as the same source name. The remaining 2 column names I am changing the column name. To do that one, you need the additional function called call. It is the existing in the one of the PYSPARK library, SQL functions library. I have imported it. Now if you display the data, the column names will be changed here. The data pricing, look at it, the data pricing column is changed into the pricing date, and the variety is changed into the variety name. This is all most likely we needed to do the transformation of the data frame. Now for each and every step I did it. Okay, if you want to, for example, if you want to write this transformed data back to your data lake storage account in any format, okay, right, you need to use the write function. You can use any of these formats here, and if you give the path name for your data lake storage account, then you are writing your transformed data back to the ADLS. Any of the transformations that we are doing it here, we can permanently able to write it here using the same keyword. Okay, so again, if you want to remove the column name from one of the column name from the existing data frame, you use the drop statement. For example, we do not need any of the columns subsequently, then we can able to drop it. The drop and selecting the specific column, this and all play the significance in executing your code. Okay, we are talking about 12 columns, but in the real time probably hundreds of columns will be there in your source file, but all of the 100 columns you may not need to produce your final output. So in the first instance itself, you will take only the columns needed for your further transformation. That means you are going to use your cluster efficiently. You are not overloading your cluster with too much of the unnecessary data. As soon as you reduce your number of columns, your Spark cluster is used effectively, and also your performance also will be very good. If without dropping 100 columns, you are applying only transformations on 2 columns, still you are including all of the 98 columns, the Spark cluster need to accommodate all of the data because you didn't remove the unnecessary columns here. Okay, and here for example, you can able to create the new column name with the expression that you are going to pass it here. Okay, I'm creating the market name column, and I'm saying that only display the market names which is existing in the state name Kerala. Okay, this is the with column function to create the new column name from the existing values. This is also possible here. probably. Not only that with column can do that one, you can able to convert the data type of your source column as well, because I'm creating the, I think I didn't create the new column name, the same column name, but I converted that into the integer. If you look at this, the arrival in tons, it's showing it as an integer, and the first data frame that when we read it, the original schema name, if you look at it, the arrival in ton is displayed as a string column. Okay, so the with column function is converting your source column into any data type or deriving new values from the existing column names. That is what with column name is used. Okay, this is again the one of the additional function, and there are three functions I think we have seen until now. One is the call function to rename the column names, and another one is select function to select the specific column names from the data frame, and we have also seen the drop. Now we have seen the with column name to derive the new column name based on the existing column name values. And here I specifically mentioned about data type conversions, and the same column name alias function also used with column renamed. So with column renamed, there are multiple ways to do the same work here. As I said, I am trying to introduce most frequently used functions in the data frame operations. Okay, so with column name can do the rename, with column name can convert the data type, with column name will derive the new value based on the existing column name values. Okay, and the filtering is the one specifically I think I would like to focus, because last week we couldn't able to cover it very properly. So now if you want to apply the filter on numerical value, specifically this arrival in tons, I have done it into the integer in the past data frame. So if you want to apply the filter on the numerical column name, you can able to use the condition inside the single quotes. This will straight away will apply the filter on the data frame. Again, storing the output of the transformed data into another data frame is standard practice, because we are transforming this data to store the transformed data somewhere else. To do that, always assign it into the data frame. But the applying the filter condition on the string values is little bit tricky. That's where the call function that we previously used will be helpful. This is just using the not null function. Again, this one you can able to give it in the quotes dot is not null. Is not null is straightforward. And to applying the filter on the string values, you can't directly apply it using this existing format, because the string values already represented by single quotes. So last week we had the problem. So what here we are using is that we are using the call function. Once you imported our column function, you can able to use it. So column of column name, we are separating it here. Actually, we are not giving inside the quotes, and column of this specific column name equal to this string values. Whenever string comparisons are needed, you need to use the call function in the filter. You can't able to directly filter like this. For the numerical values, this is possible, but for the string values, it is not possible, because the string values also represented by single quotes in the, and it is creating some unnecessary confusion here. Okay, it won't work as we expecting it. Okay, so that is the one thing last week I missed as well. So how to apply the string functions. On top of that, for example, if I remove this distinct function here, okay, Control X, yes, we got we can able to get the distinct records also from the specific column name. This is going to be mix up, select, and the distinct. So if you select all of the state names, it's giving the duplicate values on the state name values. But if you apply the distinct function also one of the frequently used function. And if you have got too much of the data, you do not want to overload the cluster while developing the code, you can use the limit to view only the limited data, and sort also you can able to order your data by specific column that you are supplying it. Here I supplied with data pricing sort, and you can able to specify the ascending order and descending order. Then you need to use the call function. So call function plays very significant role when you want to apply the specific conditions on the string and specific type of the ordering in the sort as well. There are, again I will share the notebook, nothing you need to be memorized here. The only thing it need to come in your mind is if you want to select subset of the data, okay, first of all our data is existing in outside the PYSPARK. You need to bring the data into the PYSPARK. For that you can directly use the Spark session. If the data is something, Apache Spark can be able to read it. Okay, if it's not Apache Spark directly can able to read it, we need to use the standard Python libraries to bring the data into the Python variable first, then convert that into the RDD, then convert into the data frame. Then you can able to use the Spark session. The remaining functions all will be same. Okay, so you need to be familiar with most of these functions that I have explained now. It will come in the practice. Even we are going to use these functions one more time today on when transforming our source data in the silver layer. We will open this notebook for the reference purpose while doing that one. Only one thing I want you to remember here is you can slowly get familiar with select. You will slowly familiar with call function. You will be slowly familiar with combining select and the filter, and you are slowly going to be familiar with creating the new columns from the existing columns. This is and all absolutely fine. What you need to remember in your mind is that if you need to process some data, first thing is you need to check whether that can be directly read by Spark session or not. If it can be read by Spark session, you need to know the format of the data. If you know the format of the data, there is the standard function is available for almost all of the formats. Okay, and you read it and you can assign that into the data frame. Okay, now you read your source data. Source data has got set of columns. From these set of columns, either you create the new columns from the existing columns, or you filter out some of the data from the existing columns, or you can able to do some data transformations on the specific column names. For example, converting the date into the different date format is one of the conversions will come. So the list of functions I have given it here mostly will help us for all of the operations that we have done. If some operation is going beyond our learning, all we need to do is that we need to check the specific PySpark function and see the syntax and see the example, and you need to know how to apply that. That's all we need to know.